So this is from 2019, question number 18. It came in Excel geology section. Question number 18. The enzyme that follows a Michaelis-Menten kinetics catalyzes the conversion of 35 micromolar substrate into product with a reaction velocity of 10 micromolar per second. The Km and Kcat for the substrate are 14 micromolar and 500 per second respectively. The total amount of enzyme taken for the enzyme reaction is how much? Nanomole. So I've already explained the norm. So the normal Michaelis-Menten kinetics equation is this thing, where the reaction velocity is equal to the Vmax into substrate concentration divided by the sum of Km and S, where S is the concentration of the substrate, Km is the Michaelis constant. Now, some of these are already mentioned over here. The substrate concentration, it is 35, and then we have the reaction velocity, it is given as 10. Now Km is also given, Km is 14. So we can calculate what is not given here is Vmax. But since everything else is given, we can calculate Vmax. So let's do that first. So V is 10 equal to Vmax into S is 35 divided by 35 plus 14, which is 10 into 35 plus 14 would be 49 divided by 35, which is equal to Vmax. Now if we calculate that, Vmax will come around 40 micromole per second. Okay, Vmax is 14 micromole per second, V is 10 micromole per second. Now what we have to calculate is that the total amount of enzyme taken for the reaction. Now Kcat, this can be calculated by using Kcat, which is given by Vmax into the total enzyme concentration. Now Vmax we have calculated from this equation. Kcat is given in the question, that is 500 per second. What is Kcat if you ask? Kcat represents the turnover number, that is how many substrates are getting turned over per unit time by each enzyme molecule. So this would indicate that 500 units of the substrates are getting converted into the product in 1 second per second. So Kcat is also given. Vmax is we have calculated earlier, and then we have to find the enzyme concentration. So if we just substitute that in this equation, so total enzyme would be given by Vmax divided by the Kcat. So that will be Et equal to Vmax is 14 divided by 500. Okay, so total enzyme would be somewhere around 0.028 micromolar. Okay, now you have to, now in the question it is given in nanomolar. So this thing you have to keep in mind before answering this question. Even if you have got the answer correctly, but your units are not not correct, so you will not get any marks. And this is a numerical answer type question, so you have to enter the value of your uh, the answer. So if you write here 0.028, thinking like if you have converted into micromolar, and if you write that into the answer, right? That as the answer, you will lose your mark even if you have done the entire thing correctly. So because here they have asked the enzyme in nanomolar concentration, so for that you have to multiply it by 1000, and then you would get Et equal to 28 nanomolar, and this 28 will be the answer. So answer will be 28.